All right, today we're going somewhere really special, all the way to the Himalayas. We're going to investigate one of the most profound events in our planet's entire history. And the whole story, it's preserved in this incredible archive of stone. So let's just jump right in. How in the world do you investigate a murder mystery that's 252 million years old? I mean, seriously, think about it. The victim is life itself. The crime scene is the entire planet. Where do you even start looking for clues? Well, you go to a place just like this. This is Guryul Ravine. It might look like just a quiet spot, but it holds the story of a global catastrophe, literally written in its layers of rock. This is our primary evidence. You could even call it our geological eyewitness. Right, so what we're talking about here is the Permian-Triassic extinction event. But, it's got a much more chilling nickname, the Great Dying. And believe me, it earned that name for a very, very good reason. Get this, 90%, about 252 million years ago, 90% of all marine species just vanished from the planet. Just try to wrap your head around that. 9 out of every 10 creatures in the ocean gone. That's the sheer scale of the devastation we're looking into. Okay, so when you're trying to study a global event like this, you can't have scientists just looking at scattered evidence all over the world. It would be chaos. You need a single agreed-upon benchmark, a definitive line in the sand, or, well, in this case, a line in the rock. And that benchmark has a name. It's called a GSSP. The easiest way to think about it is like a literal golden spike that geologists hammer into a rock layer somewhere in the world. And that spike basically says, right here, this exact spot is where one geological time period ends and the next one begins. It's the official marker. So for the Great Dying, that golden spike, that official reference point, is in a place called Meishan in China. And for decades, it's been the go-to spot, kind of the champion site for studying this boundary. But, and this is a big but, is it really the best place to understand the whole story? And that's where Guryul Ravine comes back into the picture. See, it's not just another location to find some fossils. It's a site that tells a much richer, way more detailed, and honestly, maybe even a more important story of how life on Earth actually collapsed. So here's what's so cool. Guryul Ravine today is nestled way up in the Himalayas. But if you could travel back 252 million years, this land wouldn't be mountainous at all. No, it was actually the floor of a huge, ancient body of water called the Tethys Ocean. And that difference in context, it's absolutely critical. You see, Meishan, the official site in China, tells the story from the perspective of an isolated little microcontinent. But Guryul tells the story of the massive Tethys Ocean itself. So let me ask you, which one do you think gives us a better picture of a truly global extinction? The little island or the world-spanning ocean? Oh, and it doesn't stop there. After decades of intense study, the site at Meishan is, well, it's been pretty beat up. It's been heavily excavated, sampled, and disturbed. Guryul Ravine, though, it's largely a natural, totally intact exposure. It's just a more pristine archive, which gives it a much higher degree of scientific authenticity. But maybe the most crucial difference of all is this. The actual layer of rock that records the extinction event, at Guryul, it's almost 3 meters thick. At Meishan, it's less than half a meter thick. Now, that huge difference in thickness means Guryul's record is basically stretched out, giving us this incredibly high-resolution view of the catastrophe as it happened. It's really like comparing a blurry old photo to a 4K video. The detail is just on another level. Okay, so what does this high-res video actually show us? Let's dig in and read the story that's written in Grinnell's rocks, layer by incredible layer. Let's start in the late Permian period, right before the disaster hits. The rocks from this time, man, they paint a picture of a vibrant, healthy, just incredibly complex marine world. I mean, these layers are just packed with fossils of all sorts of complex creatures, like brachiopods and these reef-building things called bryozoans. This is so much more than just a collection of old shells. It's the signature of a fully functional, oxygen-rich ecosystem that was absolutely humming with life. And then you move up just a few feet in the rock face, and everything changes. Bam! You've just entered the kill zone. The evidence for a sudden, catastrophic event here is just undeniable. First, all those diverse fossils, they just vanish. Poof, gone. The few creatures that do remain are dramatically smaller. It's a phenomenon scientists actually call the Lilliput effect. Then, the very chemistry of the rock itself shifts, showing massive environmental stress. And to top it all off, there might even be traces of the world's first recorded tsunami. This wasn't some slow, gradual decline. This was a sudden, violent collapse. And what came next? It was definitely not a quick recovery. The layers right above that extinction boundary, they reveal a hostile, pretty much empty world. This new post-apocalyptic world was ruled by what scientists call disaster taxa. Basically, these were simple, opportunistic creatures, like this little bivalve, that could somehow survive in the hot, low-oxygen conditions. All that rich diversity was gone. It was replaced by just a few hardy survivors, desperately clinging to life in a totally ruined world. So you might be thinking, okay, this is a fascinating story from 252 million years ago, but why does it matter to us today? Well, it's because Guryul Ravine doesn't just tell us what happened, it tells us how it happened. There's this quote that just perfectly sums up the importance of this place. It says, Meishan defines the boundary. Guryal explains the collapse. See the difference? Meishan, the official spot, is just the pin on the map. It tells you when the Permian ended. But Guryal explains the collapse itself. And that is what makes this so profoundly relevant, because it provides this detailed, step-by-step account of how an ecosystem completely falls apart under extreme stress. Guryul Ravine is like a vital playbook for climate and ecosystem scientists today. It helps us understand the warning signs in our own world. And that forces us to ask a really serious question. This ancient archive? It's not just history, it's a warning, written in stone. If this is what happens when a planet's systems get pushed past their breaking point, what is this 252 million-year-old story trying to warn us about our own future?